Imagine looking at the night sky and realizing that everything you can see, every star, every glowing nebula, every distant galaxy, makes up less than 15% of what's actually there. The rest, the vast majority of the universe, is hiding. Not behind clouds or dust, but in plain sight, holding galaxies together with invisible hands, shaping the cosmos in ways we still don't fully understand. Hello and welcome to the Sleepy Astronomer. Tonight, we're drifting into a story about shadows and revelations, about a woman who spent her life looking at what others couldn't see, and in doing so, found what everyone had missed. This is the story of Vera Rubin, born on July 23rd, 1928, who discovered that most of the universe was missing. If you're settling in for the first time, welcome to our gentle journey through the cosmos and the people who've helped us understand it. And if you've travelled with me before through distant worlds and cosmic mysteries, it's wonderful to have you back among the stars. Whether you're tucked up into bed, curled up on a favourite chair, or perhaps lying back where you can see the night sky through a window, I'm so glad you're here. Our journey begins not with telescopes or equations, but with a 10-year-old girl watching stars move across her bedroom window in Washington, D.C. It follows her through closed doors and dismissive rejections, through patient years of observation in the quiet hours when most astronomers were elsewhere, until finally the universe revealed its greatest secret, not to the loudest voice or the most prestigious institution, but to someone who had learned by necessity to look very carefully at what everyone else was overlooking. There's something almost poetic about it, really. A woman told she didn't belong in astronomy, told the field wasn't suitable for her, going on to discover that 85% of the universe had been invisible all along. The excluded observer finding the excluded matter, the person pushed into the shadows learning to study the cosmic shadows that hold everything together. In ancient wisdom traditions, there's often a pattern: the seeker who must walk in darkness before bringing light, the outsider who sees what those inside the walls cannot. Vera Rubin's life follows this arc, though she might not have described it that way. She was, by all accounts, a gentle soul, patient and methodical, more interested in understanding galaxies than in making grand pronouncements. Yet her quiet observations shook the foundations of physics and changed forever how we understand the universe we inhabit. So, find your most comfortable position, take a deep breath, and let's begin our gentle drift through a life that started in shadow and ended in revelation. A journey from a girl's bedroom window in Depression-era America to the farthest reaches of the cosmos, where darkness, it turns out, is not empty at all, but full of mysteries waiting for someone patient enough to notice them. Picture Philadelphia in the summer of 1928, where heat rises from cobblestone streets in shimmering waves and the air hangs thick with the scent of coal smoke and possibility. The stock market hasn't crashed yet. That catastrophe still waits a year away, gathering like thunder on a distant horizon, but you can almost feel the tremors if you know where to look. Into this uneasy world, on July 23rd, arrives a baby girl named Vera Florence Cooper, her first cry piercing the stillness of a modest bedroom, where her mother, Rose, holds her close and wonders what kind of future awaits this small, perfect stranger. There's no ceremony marking the moment, no cosmic announcement that something significant has just occurred. Just another birth in another immigrant family, another daughter added to the great churning experiment of America in the 1920s. Philip Cooper, Vera's father, stands at the bedside with his wire-rimmed spectacles catching the lamplight, his hands still carrying the chemical stains from his work as an electrical engineer. He looks at his daughter with the same careful attention he brings to solving problems with circuits and current, not knowing that this tiny being will one day solve problems that exist at scales so vast they make human engineering seem almost quaint. Rose Cooper, holding her newborn daughter against her chest, feels the baby's heartbeats synchronize with her own. She is an unusual woman for her time, university-educated when most women were expected to find fulfillment entirely within marriage and motherhood. Her mind moves through ideas about literature and philosophy that make her neighbours vaguely uncomfortable, as if thinking too deeply about things might somehow be dangerous for the female constitution. She traces her finger along Vera's tiny palm, perhaps wondering what these hands might one day touch, what mysteries they might unravel. The irony is almost too perfect. Here is a child who will spend her life reaching toward the farthest edges of the cosmos, born to parents who came from the far edges of Europe, carrying their own stories of displacement and determined reinvention. The family moves to Washington, D.C. when Vera is still young, settling into a neighborhood where modest homes line quiet streets and children play games that have been played for generations. Picture their house on a typical evening in the late 1930s. The smell of dinner drifting from the kitchen, the sound of Philip's footsteps as he returns from work, the particular quality of light that comes through windows in that hour before sunset when the world seems to pause and take a breath. And then picture Vera at 10 years old, lying in her bed unable to sleep, her eyes fixed on the window where something extraordinary is happening. The stars are moving, not quickly, not dramatically, but with a slow, patient progression across the frame of her window. She watches them for hours, night after night, tracking their journey across her small rectangle of visible sky. It's a simple observation, the kind that millions of children might make, but for Vera it becomes an obsession in the best possible sense, a question that won't let go, a puzzle that demands understanding. Why do they move? Where are they going? What holds them in the sky? Her parents find her this way sometimes, long past bedtime, still watching the stars drift across her window like ships on an invisible ocean. Most parents might have told her to go to sleep, to stop wasting time on idle daydreaming. But Philip and Rose Cooper, carrying their own memories of questions that went unasked and curiosities that went unexplored, do something different. They encourage her. They wonder alongside her. And Philip, with his engineer's hands and his immigrant's determination to give his daughter opportunities he never had, builds her a telescope. It's nothing sophisticated, just lenses and tubes assembled with careful attention in a basement workshop, where the smell of metal and oil mingles with sawdust and hope. But when Vera looks through it for the first time, seeing the moon's craters and mountains leaping into clarity, seeing Jupiter's moons arranged like tiny pearls on an invisible string, something crystallizes in her young mind. This is what she wants to do with her life. Not as a hobby, not as a passing interest, but as the central organizing principle of her existence. She wants to study the stars. The problem, and it's a considerable one in the 1930s, is that astronomy is a field almost entirely closed to women. Not officially, perhaps. There are no signs saying no women allowed hanging on observatory doors, but the barriers are there nonetheless, built into the culture and assumptions of the scientific establishment, like walls that have been standing so long nobody even notices them anymore. There's a shadow history here, invisible to most people but crucial to understanding Vera's journey. At Harvard College Observatory, women have been employed for decades as computers, human calculators who perform the tedious mathematical work that male astronomers rely upon but rarely acknowledge. They're paid less than the janitors, these women, yet they're doing work that will eventually revolutionize our understanding of the universe. Annie Jump Cannon sits at her desk day after day, classifying hundreds of thousands of stars according to their spectral characteristics, developing a system so elegant and useful that astronomers still use it today. Henrietta Swan Leavitt discovers a relationship between certain stars' brightness and their pulsation period, giving humanity a way to measure cosmic distances for the first time. Cecilia Payne figures out what stars are actually made of. Not the heavy elements everyone assumed, but hydrogen and helium in vast, almost incomprehensible quantities. But they're not called astronomers. They're computers, assistants, helpers. The real astronomy, the thinking and theorizing and publishing under your own name, that's reserved for men. It's an arrangement so normal, so completely accepted, that questioning it seems almost absurd. Vera is too young yet to understand all this history, too young to know the battles that have been fought and lost in the decades before her birth. She just knows she loves the stars, and that means college, and that means finding one of the very few places that will accept a woman into their astronomy program. The war years drift past like a fever dream, rationing and air raid drills and the constant low-level anxiety of knowing that somewhere, far away, young men are dying by the thousands. Vera grows up watching the night sky not just with wonder, but also with the peculiar awareness that comes from living through catastrophe. Those stars have been shining since long before the war began, and they'll be shining long after it ends. There's comfort in that continuity, in the patient indifference of the cosmos to human suffering. When she applies to Vassar College in 1945, as the war finally shudders to its end, she's following in significant footsteps. This is where Maria Mitchell taught, America's first professional female astronomer, who discovered a comet in 1847 and spent decades quietly opening doors for women in science. Walking onto that campus must have felt like stepping into a place where her dreams weren't absurd, where wanting to study the stars was a reasonable ambition rather than a foolish fancy. The war has done something interesting to American science, cracking open doors that had been sealed shut for generations. With so many men overseas, women flooded into technical and scientific work, proving they could do everything the men could do, and often doing it better. Some of them, like Vera, have no intention of going back to the way things were before. They've tasted possibility, and it's addictive. At Vassar, Vera studies astronomy with a kind of focused intensity that will characterize her entire career. She's not the loudest student, or the most flamboyant. She doesn't draw attention to herself or make grand pronouncements about her future achievements. She just works methodically and carefully, genuinely curious about how the universe operates. She falls in love with stellar spectroscopy, the way you can take light from a star millions or billions of miles away, split it into its component colours, and read in those colours what the star is made of, how hot it is, how fast it's moving. It's like the universe is speaking to you in a language made of light, if you know how to listen. Each spectrum is a story written in wavelengths, a message sent across vast distances of space and time. And somewhere during those college years, something else happens that will shape the rest of her life. She meets Robert Rubin, a physical chemistry student with kind eyes and a mind that moves through problems with the same careful attention she brings to her own work. They fall in love in the way people do when they're young, and the world still feels full of infinite possibility. They marry young. Vera is barely 20, and here's where the story could have taken a familiar turn. Young woman, newly married in the late 1940s, facing a society that insists women must choose between family and career, that having both is somehow unnatural, somehow greedy. The cultural message is everywhere. Your husband's career matters, your children need you home, your own ambitions should be satisfied by supporting others' dreams. But Robert Rubin, to his enormous credit, never asks Vera to choose. He supports her ambitions as naturally as breathing, as if the idea that she might abandon astronomy for domestic life is obviously absurd. They'll figure it out together, he tells her. There's no reason she can't be both a wife and an astronomer. The fact that the world thinks otherwise is the world's problem, not theirs. Still, when Vera graduates from Vassar in 1948, she faces a hard reality that no amount of love or support can eliminate. She wants to continue her studies, to pursue a graduate degree in astronomy. The natural place to apply is Princeton, which has one of the finest astronomy programs in the country, a place where serious scientists gather to push the boundaries of human knowledge about the cosmos. The rejection letter arrives with brutal simplicity. Women are not admitted to the graduate astronomy program. Not, "We regret that your qualifications don't meet our standards," or, "Unfortunately, we have no space in the program this year." Just no. You cannot come here because of what you are, regardless of what you know or what you might discover. Sit with that for a moment. Picture Vera holding that letter, reading those words, feeling the weight of institutional rejection settling onto her shoulders like lead. Here is a young woman with a degree in astronomy, with passion and talent and questions burning in her mind about how galaxies move through space, and the response from one of America's premier institutions is simply, "You don't belong here because you're a woman." Princeton won't admit women to its graduate astronomy program until 1975. By then, Vera Rubin will already have made the discovery that changes our understanding of the universe. They'll miss their chance to be part of that story, all because of a policy that seems, in retrospect, almost cosmically short-sighted. So Vera goes to Georgetown University instead, where they have a master's program in astronomy, and more importantly, where they'll admit her. She works on her degree in the evenings, fitting her studies into the margins of a life that's already being shaped by the expectations placed on young married women in the 1950s. She has a day job, she has a home to manage, and she has the work she loves, all of it demanding attention, all of it pulling her in different directions at once. And here's where we start to see a pattern that will repeat throughout her life, a pattern that transforms exclusion into insight. Being pushed to the margins gives her a different perspective, a different way of looking at problems. Those who work in shadow learn to notice what others standing in bright light might miss. The excluded observer develops habits of careful attention, of questioning assumptions, of looking very carefully at what everyone else is overlooking. Her master's thesis explores the distribution of galaxies in space. Are they scattered randomly like stars appear to be in our night sky, or do they cluster together in larger patterns? It's 1954. The idea of large-scale structure in the universe is barely formed yet, still floating in the realm of speculation rather than established fact. But Vera, working in the evenings at Georgetown while raising a young child, is already beginning to ask the questions that will consume the rest of her career. She's learning something crucial during these years, though she might not name it as such at the time. She's learning patience. She's learning to work carefully and methodically, to let the data speak rather than imposing her expectations on it. She's learning to be comfortable in the quiet places, the overlooked corners, the shadows where most astronomers aren't looking. Picture her at her desk late at night, after her young son Robert has finally fallen asleep, after the dishes are washed and the house has settled into that particular silence that comes when everyone else is resting. The lamplight creates a small pool of illumination in the darkness, and within that pool, Vera works through calculations that trace the positions of galaxies across millions of light-years of space. Her handwriting flows across the page, equations and observations, questions and tentative answers. The 1950s settle in with all their rigid domesticity, their strict ideas about what women should want and how they should behave. Television shows portray perfect housewives in perfect homes, always smiling, always satisfied with lives lived entirely in service to husbands and children. The cultural pressure is immense, constant, like gravity pulling everything toward a single, acceptable configuration. And here is Vera Rubin, trying to do something that society insists is impossible. She and Robert start a family. They'll eventually have 4 children, while Vera pursues a career in astronomy. Think about that for a moment. In an era when women were told they had to choose between family and career, when the cultural message was clear that mothers belonged at home, Vera is trying to do both. Not because she wants to prove a point necessarily, but because she loves her children and she loves astronomy, and she can't see why she should have to sacrifice one for the other. It's an impossible juggling act, of course. It always is. There are missed bedtimes and tired mornings, moments of guilt and frustration, the constant feeling of being pulled in too many directions at once. Some nights she falls into bed exhausted, wondering if she's failing at everything. Failing as a mother, failing as a scientist, failing as a wife. But there are also children who grow up understanding that their mother is doing something important, something that matters beyond the walls of their home. There are young minds learning that curiosity and persistence matter, that the universe is worth studying, that women can be scientists not just in theory, but in lived reality. And Robert, throughout all of it, remains her partner in the fullest sense. He doesn't just tolerate her career, he actively supports it. He helps with the children, encourages her research, believes in her work with a conviction that never wavers. In a time when such partnership is rare enough to be remarkable, it makes all the difference. At Georgetown, Vera finds a mentor who will change the trajectory of her career. George Gamow is a brilliant cosmologist, someone whose mind moves through the biggest questions about the universe with the same playful curiosity that Vera brings to her own work. More importantly, he's someone who doesn't seem to care much about the unwritten rules that say women don't belong in certain spaces. He sees something in this quiet young woman who's working on her doctorate while raising small children. He sees someone who asks good questions, who looks at problems from interesting angles, who isn't satisfied with easy answers. He encourages her, pushes her thinking, helps her see that the questions she's asking about galactic structure are important, even if the astronomical establishment isn't paying attention yet. For her doctoral thesis, Vera returns to the question of how galaxies are distributed in space. The prevailing assumption among astronomers is that galaxies are scattered more or less randomly through the universe, like stars appear to be scattered randomly across our night sky. But Vera's careful observations suggest otherwise. There are patterns, structures, clustering on scales much larger than anyone expects. Her early papers gained some attention, though mostly of the skeptical variety. The establishment isn't ready to hear that the universe has structure on such grand scales. It will be decades before satellites and surveys map the cosmic web she glimpsed in those Georgetown years, before her early insights are fully appreciated. But that's fine. Vera is patient. She's learned to be. By the early 1960s, she has her doctorate, 4 children, and a faculty position at Georgetown. She's teaching classes, conducting research, slowly building a body of work. She's not famous, Not at a prestigious institution, not doing anything that the astronomical establishment considers particularly important. She's working in what most of the field would consider the shadows, a woman at a teaching college, pursuing observations that seem interesting but not groundbreaking. And it's precisely there, in those shadows, that she's preparing to find what everyone else has missed. The invisible matter holding the universe together, the dark substance that makes up most of what exists, yet had somehow escaped detection until a woman who'd been told she didn't belong in astronomy looked very carefully at the way galaxies spin. But that discovery is still ahead of her. In these early 1960s years, Vera is still gathering tools and experience and perspective. She's working with a new collaborator named Kent Ford, who has developed a sensitive spectrograph that can measure the velocities of stars in distant galaxies with unprecedented precision. Together, they're about to point that instrument at the Andromeda Galaxy, expecting to confirm what everyone already knows about how galaxies rotate. Instead, they're going to find something impossible, something that will require an entirely new understanding of what the universe is made of. But we're getting ahead of ourselves. Let's stay in these early years a moment longer, in the time before the revelation, when Vera is still in the shadows, still watching, still questioning, still being patient, learning the skills that will let her see what no one else can see, preparing, though she doesn't know it yet, to unveil the missing universe. Picture a quiet street in suburban Washington, D.C., on a summer evening in 1954, where the air hangs thick and still, carrying the scent of freshly cut grass and honeysuckle blooming along white picket fences. Inside one modest house, the sounds of family life drift through open windows, a child's laughter, dishes clinking in the sink, the soft murmur of a radio playing somewhere in the background. In an upstairs bedroom, a small boy named Robert sleeps with the particular abandon that only young children manage, one arm flung above his head, his breathing deep and regular. And in a room down the hall, Vera Rubin sits at a desk that's really just a small table pushed against the wall, surrounded by papers covered in numbers and calculations that trace the positions of galaxies millions of light-years away. The lamplight catches the edge of her face, illuminating the concentration there, the slight furrow between her eyebrows, as she works through equations that describe how vast collections of stars move through the darkness of space. Outside, crickets begin their evening song. Inside, Vera is travelling to the edge of the universe without ever leaving her chair. There's something almost heartbreaking about the scene, if you know what to look for. Here is someone capable of understanding the largest structures in the cosmos, and she's working in whatever hours she can steal from a life that demands her attention in a dozen different directions at once. She's earned her doctorate now, Dr. Vera Rubin, though the title feels strange on her tongue, like wearing clothes that don't quite fit. The astronomical establishment still sees her as an outsider, a woman playing at science while her real responsibilities wait at home. Princeton's rejection still stings when she lets herself think about it. Not the rejection itself, exactly. She'd half expected that. But the casual brutality of it, the way they didn't even pretend there was another reason. Women are not admitted to the graduate astronomy program. Full stop. As if her gender were a disability that prevented her from understanding mathematics, from reading spectrographs, from asking questions about how the universe works. Princeton won't change that policy until 1975. Vera will be 47 years old by then, with a discovery behind her that will reshape humanity's understanding of the cosmos. They'll have missed their chance entirely, all because they couldn't imagine that someone who happened to be born female might have something to contribute to their understanding of reality. But that's still ahead of her. Right now, in this quiet room with the crickets singing outside, Vera is just beginning to understand what it means to work in the shadows. Georgetown has given her a faculty position, which is more than many women in her situation receive. She teaches classes during the day, undergraduate astronomy mostly, young people who are curious about the stars but who may never pursue it seriously. She prepares lectures, grades papers, holds office hours where students come with questions that range from brilliantly insightful to heartbreakingly confused. And then there are her own children. Robert is 3 years old now, full of questions and energy and the particular chaos that small children bring to every moment. Lucy will arrive in a few years, then David, then Judith. 4 children, eventually. 4 complete human beings who will need to be fed and clothed and loved and guided into adulthood, each one deserving her full attention. Watch her on a typical day, and you'll see the impossible juggling act that becomes her life. Morning begins before dawn. There's no sleeping late when you have a toddler. She makes breakfast while Robert plays with blocks on the kitchen floor, builds towers and knocks them down with gleeful destruction. The radio plays news about Eisenhower and the Cold War, about nuclear testing in Nevada and Soviet satellites. The world is changing quickly, growing more dangerous, though you wouldn't know it from the cheerful advertisements that interrupt the news. Buy this detergent. Try this cake mix. Be a better housewife. After breakfast, there's the commute to Georgetown, her mind already shifting gears from mother to teacher. She stands in front of classrooms full of young men, and a few young women, though not many, and tries to convey the wonder of what they're studying. The Andromeda Galaxy, visible on a clear night as a faint smudge in the sky, is actually a vast spiral of hundreds of billions of stars, so distant that the light reaching our eyes left before humans existed, in anything we'd recognize as civilization. Some students get it. You can see their faces light up when they grasp the scale of what they're learning, when they understand that astronomy isn't just memorizing facts, but learning to see reality as it actually is, rather than how it appears. Others are there because they need a science credit, and they'll forget everything the moment they turn in their final exam. Vera teaches them all with the same patient attention, planting seeds that may or may not take root. And then, after classes and office hours and faculty meetings that seem designed to waste everyone's time, she rushes home to relieve the babysitter. There's dinner to make, laundry to fold, a small boy who wants stories before bed. Robert has lately become fascinated by rockets. It's 1954, and space travel is still firmly in the realm of science fiction, but children don't know what's impossible yet. He wants to know if people will ever go to the moon, if there might be aliens on Mars, if the stars are really other suns. Vera answers his questions as best she can, finding joy in his curiosity even as exhaustion settles into her bones. This is what it means to have both, to be both scientist and mother, to inhabit both worlds at once. Some nights she falls into bed wondering if she's doing either role justice, if she's failing her son by being too focused on distant galaxies, failing her students by being too tired to give them her best thinking. But Robert, young as he is, seems to thrive on seeing his mother work. He's learning something that many children never learn, that women can be scientists, that mothers can have important work beyond the walls of home, that curiosity matters more than convention. Her doctoral work under George Gamow has taught her things beyond astronomy. Gamow himself is a study in contrasts, brilliant and playful, capable of the deepest theoretical insights, yet somehow maintaining a childlike delight in asking questions. He treats Vera the way he treats his male students, with the same expectations and the same encouragement. When she shows him her calculations about galactic clustering, he doesn't pat her on the head and tell her it's interesting for a woman. He engages with the work itself, asks probing questions, pushes her to think more deeply. Their conversations often happen in his office, a cluttered space that smells of pipe tobacco and old books, where papers pile up in drifts that seem to have their own internal logic. Gamow sits with his feet on the desk, gesturing with his pipe as he talks about the expanding universe, the microwave background radiation that might still exist from the Big Bang, the strange quantum effects that govern the smallest scales of reality. The galaxies, he says, tapping his pipe against an ashtray, they don't distribute randomly. You're seeing something real, Vera. The question is what it means. She's proposed that galaxies show large-scale structure, that they cluster together in ways that suggest the universe has organization at the grandest scales imaginable. Most astronomers assume the cosmos is essentially uniform when you zoom out far enough, galaxies scattered like grains of sand on a beach with no overall pattern or structure. But Vera's observations suggest otherwise. There are patterns, clustering structure that extends across hundreds of millions of light years. The skepticism she encounters isn't hostile exactly. It's more like polite dismissal, the kind you give to ideas that might be interesting but probably won't pan out. Her papers get published in specialist journals, and a few colleagues cite her work, but the broader astronomical community isn't ready to hear that the universe has structure on such vast scales. It conflicts with their assumptions, with their understanding of how cosmic evolution works. But Vera is learning patience during these years, the kind that comes from working in spaces where you're not entirely welcome, where every achievement requires twice the effort for half the recognition. She's learning to let the data speak for itself, to trust her observations even when they contradict prevailing theories. Most importantly, she's learning to be comfortable in the shadows, in the overlooked corners where important discoveries sometimes hide. The 1960s arrive like a sudden storm after a long drought. Everything changes at once: the music, the politics, the sense of what's possible. Young people are questioning authorities that seemed immutable just a few years earlier. The civil rights movement is forcing America to confront centuries of injustice that had been carefully ignored. Women are starting to ask dangerous questions about why they should be satisfied with lives that feel like beautiful prisons. Betty Friedan publishes The Feminine Mystique in 1963, giving voice to what she calls the problem that has no name, the quiet desperation of educated women whose lives consist entirely of serving others, whose own ambitions have been filed away like embarrassing mistakes. The book becomes a phenomenon because it names something that millions of women have been feeling but couldn't articulate. Vera reads it and recognizes her own struggles in Friedan's words, though she's already found ways to resist the limitations Friedan describes. And then in 1965, something happens that will change the trajectory of Vera's career entirely. The Carnegie Institution of Washington, specifically their Department of Terrestrial Magnetism, offers her a position. The name sounds like a mismatch at first. Terrestrial magnetism doesn't seem to have much connection to distant galaxies, but Carnegie's DTM has evolved beyond its original focus, becoming one of the few places where women can do serious astronomical research without constantly fighting for legitimacy. More importantly, Carnegie has resources. They have instruments, time, support for extended observing runs at major telescopes. They have a culture that values patient, careful observation over flashy theoretical pronouncements. They have colleagues who judge work by its quality rather than by the gender of the person doing it. Vera is 37 years old when she accepts the position. She's been working toward this moment for nearly 3 decades, since that first night as a 10-year-old girl watching stars move across her bedroom window. The journey has taken her through rejections and dismissals, through impossible juggling acts between family and career, through years of work that went largely unrecognized by the broader astronomical community. But she's survived. More than survived. She's preparing for something that will justify every struggle, every moment of doubt, every hour stolen from sleep to pursue the questions that won't leave her alone. At Carnegie, she begins working with a man named Kent Ford, and this partnership will become one of the most productive in the history of astronomy. Ford is an instrumentalist, someone who builds the tools that make new discoveries possible. He's developed an image tube spectrograph, a device that can measure the velocities of stars in distant galaxies with unprecedented precision and sensitivity. Picture them in an observatory on a cold night in the late 1960s. The telescope dome opened to reveal stars so numerous they blur together into rivers of light. Inside, it's chilly enough that their breath makes small clouds in the air. Ford adjusts the spectrograph with careful attention, his hands steady despite the cold, while Vera prepares the observation log where she'll record everything they see. They're about to begin a project that seems straightforward, almost boring in its simplicity. They're going to measure how stars move within the Andromeda Galaxy, the nearest large spiral galaxy to our own Milky Way, close enough that we can make out individual stars in its outer regions. Astronomers have been studying Andromeda for decades. Everything about how galaxies rotate should be well understood by now. Except it's not. And what Vera and Kent are about to discover will require rewriting our understanding of what the universe is made of. But that revelation is still ahead. Right now, in these preparatory years, Vera is simply doing what she's always done, asking careful questions, making precise observations, letting the universe reveal itself according to its own schedule rather than human expectations. She's worked in the shadows long enough. She's learned to see what others miss, to notice patterns that aren't supposed to be there, to trust her observations even when they contradict everything the establishment believes. The stage is set, the instruments are ready, and somewhere in the darkness waiting to be discovered is the missing universe, the invisible matter that holds galaxies together, that shapes the cosmos at its largest scales, that makes up most of what exists yet has somehow remained hidden until now. Until a woman who learned to work in shadows turns her attention to the cosmic shadows themselves. The Andromeda Galaxy hangs in the autumn sky like a whispered secret, a faint smudge of light visible to the naked eye, if you know exactly where to look, and the night is dark enough. To ancient observers, it was just another fuzzy patch among the stars, mysterious but not particularly remarkable. But through a telescope, Andromeda reveals itself as something far more magnificent, a vast spiral of hundreds of billions of stars, so distant that the light reaching our eyes began its journey before humans had language, before we had fire, before we were anything we'd recognize as human. Vera Rubin has been thinking about Andromeda for months, planning the observations that will map how stars move within its spiral arms. It's late 1960s now, and she's finally at Carnegie with the resources and time to pursue questions that have been accumulating in her mind for years. The work seems straightforward, almost routine. Astronomers have been studying how galaxies rotate for decades. The physics should be well understood by now. Matter attracts matter through gravity, and the gravitational pull of all that accumulated mass should determine how fast stars orbit around the galactic center. The mathematics is elegant in its simplicity. Stars near the centre of a galaxy orbit faster than those farther out. Just like planets in our solar system, Mercury races around the Sun, while distant Neptune plods along at a leisurely pace. This is basic Newtonian gravity, the same physics that Isaac Newton worked out 3 centuries ago by watching apples fall and wondering why the moon doesn't fall too. But Vera has learned over her years of working in the margins and shadows to trust observations over assumptions. Theory is beautiful, but the universe doesn't care about human theories. It does what it does, following rules we're still learning to understand. So when she and Kent Ford point their spectrograph at Andromeda, they're not assuming they know what they'll find. They're listening to what the galaxy has to tell them. The observations happen over many nights, each one a marathon of patience and precision. Imagine the scene, a telescope dome perched on a mountaintop, far from city lights, the air so clear and cold it hurts to breathe. Inside, Vera and Kent work through the night, their movements choreographed by years of practice. The telescope tracks Andromeda across the sky with mechanical patience, compensating for Earth's rotation to keep the galaxy centered in the eyepiece. The spectrograph does its quiet work, splitting starlight into rainbows that contain more information than any rainbow you've seen painted across the sky after summer rain. Each wavelength tells a story: what elements are present, how hot the stars are, and most importantly for Vera's work, how fast they're moving toward or away from us. When an object moves toward you, its light shifts toward blue wavelengths. When it moves away, the light shifts toward red. This Doppler shift, the same effect that makes a train's whistle change pitch as it passes, becomes a precise measuring tool for mapping galactic rotation. Night after night they gather data. Vera records each observation in notebooks, her handwriting flowing across pages by dim red light that won't ruin their dark adaptation. The numbers accumulate slowly, building toward a complete picture of how Andromeda rotates. It's tedious work, requiring concentration that doesn't waver even as exhaustion settles in during the cold hours before dawn. But this is what astronomy is, really. Not dramatic revelations and sudden insights, but patient observation over weeks and months and years, letting the universe reveal itself at its own pace. And then, as the data starts to come together, Vera notices something that doesn't make sense. The stars in Andromeda's outer regions are moving too fast. Much too fast. Let her sit with this for a moment, checking and rechecking her calculations, wondering if she's made a mistake somewhere. The observations themselves are clear. She can see the spectral lines shifted by exactly the amount she's measuring, but the implications of those measurements challenge everything astronomers think they understand about how galaxies work. According to Newton's laws, stars far from a galaxy's centre should orbit more slowly than those closer in. Most of a galaxy's visible mass is concentrated in its bright central bulge, so stars in the outer spiral arms should feel less gravitational pull. They should move at stately speeds, taking their time as they circle the distant centre. But Andromeda's outer stars aren't moving slowly at all. They're racing around the galaxy at speeds that match or even exceed those of stars much closer to the centre. It's as if something is pulling on them, something with enormous mass. Yet when Vera looks at images of Andromeda's outer regions, there's nothing there. Just the dark space between spiral arms, sprinkled with a few scattered stars. The first assumption, of course, is instrument error. Maybe the spectrograph is miscalibrated, maybe there's some systematic problem with how they're making measurements. Vera and Kent go over everything with methodical care: the optical alignment, the wavelength calibration, the data reduction process. They find nothing wrong, the measurements are solid. So they observe Andromeda again, and again. Each new set of observations confirms the original findings. The rotation curve, the graph showing how orbital velocity changes with distance from the galactic center, remains stubbornly flat when it should be dropping off. Stars in the outer reaches of the galaxy are moving as fast as those much closer to the center, defying every expectation based on the visible matter they can see. Vera shows the data to colleagues, and their responses follow a predictable pattern. First, skepticism. Surely there must be an error somewhere. Then, as the quality and consistency of the observations become undeniable, a kind of puzzled acceptance. The data is what it is, but what does it mean? There are only a few possible explanations, and all of them are unsettling. Either Newton's laws of gravity don't work at galactic scales, which would overturn 3 centuries of physics, and require rewriting our understanding of how the universe operates. Or there's matter in galaxies that we can't see. Lots of matter. In fact, most of the matter in galaxies would have to be invisible, detectable only through its gravitational effects. Vera, characteristically cautious, doesn't rush to conclusions. One anomalous galaxy could be just that, an anomaly, an exception to the rules. To establish a pattern, she needs more data. So she and Kent begin a systematic survey of spiral galaxies, measuring rotation curves for galaxy after galaxy after galaxy. They observe dozens of spirals over the next several years, each one requiring multiple nights of telescope time, each one adding to the growing collection of rotation curves. And with each new galaxy, the pattern holds. The outer stars move too fast. The rotation curves stay flat when they should drop off. The visible matter can't account for the observed velocities. There's a kind of quiet drama in this accumulation of evidence, like watching a storm gather on the horizon. Each new observation adds another cloud to the growing darkness, another piece of data that can't be explained by conventional understanding. Vera presents her findings at conferences, and the response shifts from skepticism to something more complex. A reluctant acknowledgement that she's uncovered something genuinely mysterious, coupled with resistance to accepting what that mystery might mean. The implications are staggering if you follow them through to their logical conclusion. If galaxies contain vast amounts of invisible matter, matter that doesn't emit light, doesn't absorb light, doesn't interact with electromagnetic radiation in any detectable way, then most of the universe has been hidden from us. Everything we can see through telescopes, all the shining stars and glowing nebulae, all the brilliant galaxies scattered across cosmic distances would represent just a small fraction of what actually exists. Some astronomers propose alternative explanations. Maybe there are large populations of faint stars that aren't being counted, dim red dwarfs or dead stellar remnants that contribute mass without contributing much light. Vera and others look for these objects, but the numbers don't work out. You'd need so many faint stars to account for the observed rotation curves that they'd have other effects we should be able to detect. The invisible mass isn't just dim, it's dark in a more fundamental way. Kent Ford, working alongside Vera through all of this, becomes her perfect complement. Where Vera is cautious and methodical in interpreting data, Kent is meticulous in ensuring the data is beyond reproach. Together, they build a case so solid that even skeptics can't dismiss it. The observations are real, the pattern is consistent, and something profound about our understanding of the cosmos needs to change. But there's resistance, of course. There's always resistance when new observations challenge established understanding. Some of it comes from genuine scientific caution. Extraordinary claims require extraordinary evidence, and the claim that most of the universe is invisible certainly qualifies as extraordinary. Some of it comes from the natural human tendency to protect ideas we've invested our careers in, And some of it, though rarely stated openly, comes from the fact that this revolutionary finding is being presented by a woman who wasn't supposed to be doing astronomy in the first place. Vera handles the skepticism with the same patient determination she's brought to every obstacle in her career. She doesn't argue or defend, she just keeps presenting data. Here are the observations, here are the rotation curves, here's what they tell us. You can accept it or not, but the universe doesn't care about your preferences. It is what it is. The term dark matter begins to circulate in astronomical discussions, though its meaning evolves over time. Initially, it's just a placeholder name for whatever is causing the anomalous rotation curves. Dark matter. Matter that's dark, that doesn't shine. Simple, descriptive, carrying no assumptions about what it actually is. But as more observations accumulate, as more galaxies show the same flat rotation curves, as other lines of evidence begin pointing toward invisible mass throughout the universe, dark matter transforms from a placeholder into a genuine mystery. If it exists, and the evidence increasingly suggests it must, then what is it made of? Why doesn't it interact with light? How did it form, and how is it distributed through space? These questions will occupy astronomers and physicists for decades, continuing to this day. Dark matter becomes one of the great unsolved mysteries of modern science, a cosmic puzzle that touches everything from the smallest scales of particle physics to the largest structures in the universe. And at the center of this mystery, making the observations that revealed its existence, is Vera Rubin, the woman who learned to work in shadows, now uncovering the shadows that hold the cosmos together. There's poetry in this that Vera herself might not emphasize, but that others certainly notice. Here is someone who was excluded from astronomy, told she didn't belong, pushed to the margins of her field. And from those margins, she discovers that most of the universe itself has been excluded from our observations, hidden in cosmic margins we didn't know existed. The excluded observer finding the excluded matter, the invisible woman revealing the invisible universe. But Vera would probably roll her eyes at such poetic interpretations. She's a scientist, focused on observations and evidence, not on symbolic meanings. Still, there's something undeniably fitting about the parallel. Her experience of being overlooked and underestimated has taught her to look carefully at what others are overlooking, to question assumptions about what should and shouldn't be there. The late 1970s find Vera's dark matter observations beginning to gain broader acceptance in the astronomical community. It's not that everyone suddenly agrees dark matter exists. Science doesn't work through unanimous consensus, but enough evidence has accumulated that serious scientists have to take the possibility seriously. Theoretical physicists begin proposing candidates for what dark matter particles might be, while astronomers search for other ways to detect its gravitational influence. Galaxy clusters show similar evidence of unseen mass. The velocities of galaxies within clusters are too high to be explained by the visible matter alone. Gravitational lensing, the way massive objects bend light from more distant sources, reveals the presence of matter in places where nothing visible exists. All of these observations point toward the same conclusion. The universe contains far more matter than we can see, and that invisible matter plays a crucial role in shaping cosmic structure. Vera continues her observations, refining the rotation curves, extending measurements to galaxies of different types and at different distances. Each new data point adds to the growing body of evidence. She's not trying to prove dark matter exists. She's simply reporting what the observations show and letting others draw their own conclusions. The data speaks for itself, she believes, and her job is to make sure that voice is heard clearly. There's a kind of vindication in watching her early work on galactic clustering gain new significance in light of dark matter. Those patterns she saw decades ago, those suggestions of large-scale structure that seemed so controversial at the time, make perfect sense if dark matter exists. The invisible matter would clump together through gravity, and visible matter, stars and gas, would fall into those clumps, creating the patterns of clustering Vera observed. She's been right all along, in other words, about things the astronomical establishment wasn't ready to hear. But Vera, characteristically, doesn't gloat or claim vindication. She just keeps working, keeps observing, keeps letting the universe reveal its secrets to anyone patient enough to listen. As the 1970s give way to the 1980s, Vera Rubin has become one of the most respected observational astronomers in the world. The woman who was denied admission to Princeton, who worked in the margins while raising 4 children, who spent decades being politely dismissed by the establishment, is now recognized as someone who fundamentally changed our understanding of the cosmos. But she's still, in many ways, the same person who stayed up late as a 10-year-old girl, watching stars move across her bedroom window. Still curious, still patient, still asking questions about how the universe works and trusting observations over assumptions. The darkness she's discovered isn't empty. It's full of matter that shapes galaxies, holds them together, determines their evolution across billions of years of cosmic time. This darkness has substance and meaning, even if we can't see it directly. And somehow that feels appropriate for someone who spent so much of her career working in the shadows cast by institutional prejudice. Vera Rubin looked into the darkness and found that it was holding everything together all along. The missing universe was there the whole time, waiting for someone to notice it. All it took was someone willing to look carefully, to trust what the observations showed even when it contradicted everything people thought they knew. The excluded observer had found the excluded matter, and in doing so, she'd revealed that the cosmos is far stranger, far richer, far more mysterious than anyone had imagined. The universe we can see, it turns out, is just a small island of light in an ocean of darkness that's only beginning to reveal its secrets. There's a moment in scientific discovery that's hard to describe to those who haven't experienced it, the moment when scattered observations suddenly coalesce into a pattern, when confusion crystallizes into clarity, when you realize that what you've been seeing isn't noise or error, but signal, a message from the universe that changes everything. For Vera Rubin, that moment arrives gradually rather than all at once, building across years of observations like a photograph slowly developing in chemical baths, galaxy after galaxy showing the same impossible rotation curves, star after star moving too fast in the outer reaches where visible matter grows sparse. The pattern holds with such stubborn consistency that denying it becomes more difficult than accepting it. By 1970, Vera has observed enough galaxies to know beyond reasonable doubt that something fundamental is wrong with our understanding of how they work, or rather, something fundamental is missing. The visible matter, all those brilliant stars, all that glowing gas, everything telescopes can detect through light, accounts for only a fraction of the mass needed to hold galaxies together. The rest is hiding somehow, present through its gravitational effects, yet invisible to every instrument astronomers have developed. The implications settle over the astronomical community like snow falling in the mountains, slowly at first, then accumulating into something impossible to ignore. If Vera's observations are correct, and by now few serious scientists doubt they are, then most of the universe has been hiding in plain sight. Everything we've been studying, all the shining stars and brilliant nebulae, represents just the visible tip of a cosmic iceberg. Beneath the surface, invisible matter holds everything together with patient gravitational hands. Imagine the scene at an astronomical conference in the mid-1970s, where Vera presents her findings to a room full of colleagues who've spent their careers studying galaxies. The lights dim as she shows slide after slide of rotation curves, each one defying the expectations built on centuries of observational astronomy. The curves should drop off at large distances from galactic centers, following the predictions of Newtonian gravity applied to visible matter. Instead, they remain stubbornly flat, as if something invisible is pulling stars along at speeds that shouldn't be possible. The questions that follow her presentation reveal the struggle happening in scientific minds, the tension between accepting observations and abandoning comfortable assumptions. Could there be measurement errors? Vera has anticipated this. She shows the careful calibrations, the repeated observations, the consistency across different instruments and different observatories. Could there be exotic populations of dim stars we're missing? The calculations don't support this. You'd need implausibly large numbers of faint objects to account for the missing mass. One by one, the alternative explanations fall away like scaffolding removed from a completed building. What remains is the structure of evidence itself, solid and undeniable. Galaxies contain far more matter than we can see. This matter doesn't emit or absorb light in any detectable way. It interacts with ordinary matter primarily through gravity. And it's not a minor component. It dominates the mass budget of every galaxy Vera has observed. The term dark matter gains currency during these discussions, though its meaning remains frustratingly vague. Dark matter is defined more by what it isn't than what it is. It isn't stars. It isn't gas or dust. It isn't anything that interacts with electromagnetic radiation in ways we can detect. It's the gravitational shadow of something unknown, the fingerprint of an invisible hand shaping galactic evolution. Kent Ford continues working alongside Vera through these years of revelation, their partnership embodying the collaborative nature of astronomical discovery. While Vera focuses on observations and data analysis, Kent refines the instruments that make those observations possible. Together, they build a case so comprehensive that even the most skeptical colleagues have to acknowledge something profound is happening. The observations expand beyond rotation curves to include other evidence of invisible mass. Galaxy clusters, vast collections of hundreds or thousands of galaxies bound together by gravity, show similar anomalies. The velocities of galaxies within clusters are too high to be explained by visible matter alone. It's as if the clusters are embedded in halos of dark matter, invisible cocoons that hold everything together. Fritz Zwicky had noticed this problem decades earlier, observing the Coma cluster in the 1930s and proposing that dark matter must exist to explain the observed velocities. But Zwicky's work was largely dismissed, filed away as interesting but not particularly important. Now, with Vera's systematic observations of galaxy rotation curves providing independent confirmation, Zwicky's insights gain new credibility. He was right, it seems, though few people listened at the time. There's a pattern here that Vera recognizes from her own experience. Ideas dismissed when first proposed, only to be vindicated decades later when new observations force reconsideration. Scientific progress doesn't always move in straight lines. Sometimes it meanders, doubles back, rediscovers truths that were glimpsed and forgotten. The theoretical implications of dark matter ripple outward through multiple fields of physics. Particle physicists begin proposing candidates for what dark matter particles might be. Exotic entities with names like WIMPs, weakly interacting. Massive particles and axions, predicted by theories but never detected in laboratory experiments. Cosmologists realize that dark matter must play a crucial role in structure formation, seeding the gravitational wells that allowed galaxies to coalesce from the smooth early universe. Vera watches these theoretical developments with interest, but maintains her focus on observations. She's not trying to solve the mystery of what dark matter is. That's a question for particle physicists and theorists. Her contribution is simpler and more fundamental, establishing beyond doubt that dark matter exists, that its effects are real and measurable, that the universe contains far more than meets the eye. Awards begin arriving during these years, recognition from institutions that once would have dismissed her work or overlooked her contributions. The National Medal of Science, the Gold Medal of the Royal Astronomical Society, honorary doctorates from universities around the world. Each honor acknowledges not just her discovery of dark matter evidence, but her decades of patient, careful work that built the foundation for that discovery. But perhaps the most meaningful recognition comes from younger astronomers, particularly women, who see in Vera's career proof that persistence matters, that patient observation can reveal truths that flashier approaches miss, that being excluded from the mainstream can sometimes provide perspectives the mainstream needs. She becomes a mentor to many, encouraging them with the same gentle support that George Gamow once provided her. Her family watches this transformation with pride tinged with the complexity that comes from years of juggling competing demands. Robert, Lucy, David and Judith have grown up watching their mother balance astronomical research with family life, seeing her steal hours from sleep to work on observations, witnessing the patience required to build a scientific career, while also being present for school plays and birthday parties and all the small moments that constitute childhood. They've also seen the costs, the exhaustion, the guilt, the constant pressure of trying to meet expectations in multiple domains simultaneously. But they've learned something valuable from watching Vera navigate these challenges. That important work is worth the struggle, that curiosity deserves to be pursued, that women can be scientists not just in theory, but in daily practice. Robert Rubin, Vera's husband, remains her steadfast supporter through all of this, providing the partnership that makes her dual life possible. His willingness to challenge conventional assumptions about gender roles in the 1950s and 60s has enabled Vera's career in ways that can't be overstated. In a time when most men expected their wives to subordinate all personal ambitions to family needs, Robert treats Vera's work as equally important to his own. The dark matter story continues to unfold through the late 1970s and into the 1980s, with each new observation adding layers of complexity to what initially seemed like a simple mystery. Computer simulations show that dark matter must be distributed in vast halos around galaxies, extending far beyond the visible edges. These halos aren't just passive containers, but active participants in galactic evolution, influencing how galaxies form, merge, and develop over cosmic time. Gravitational lensing provides another independent line of evidence. When light from distant galaxies passes through regions of space containing massive objects, the light bends and distorts in ways that reveal the distribution of mass along the light path. Observations of lensing effects show clearly that mass exists in regions where nothing visible appears, exactly what dark matter predicts. The cosmic microwave background radiation, that faint glow left over from the Big Bang, carries subtle patterns that encode information about the universe's matter content. As instruments improve and measurements become more precise, cosmologists find that the patterns in this ancient light require dark matter to exist. The universe's geometry, its expansion history, its structure on the largest scales, all of it points toward the same conclusion that Vera's rotation curves revealed. Most of the universe's matter is dark. By the mid-1980s, the existence of dark matter has moved from controversial hypothesis to established fact within the scientific community. Debates continue about what dark matter is made of, how it's distributed, how it interacts with ordinary matter beyond gravity. But the fundamental reality that invisible matter dominates the mass budget of the universe is no longer seriously disputed. Vera's role in this transformation from mystery to established science is recognized by her peers, though she characteristically deflects credit to the collaborative nature of scientific discovery. She points to Fritz Zwicky's early insights, to the work of other astronomers who studied galaxy dynamics, to the instrumentalists like Kent Ford, whose technological innovations made precise measurements possible. Science, she insists, is a collective endeavor, built on contributions from many minds working towards shared understanding. But there's no denying that Vera's patient, systematic observations provided the crucial evidence that forced the astronomical community to take dark matter seriously. Her rotation curves remain the clearest, most direct demonstration that galaxies contain far more mass than we can see. Future observations will refine and extend her work, but they'll build on the foundation she established through decades of careful measurement. There's profound irony in the fact that someone excluded from mainstream astronomy, someone told she didn't belong in the field, made one of the most fundamental discoveries about the universe's composition. The woman pushed into shadows revealed that shadows hold the cosmos together. The invisible researcher found the invisible matter. The parallel is almost too perfect, as if the universe itself were making a point about the value of perspectives from the margins. Vera would probably laugh at such poetic interpretations, preferring to focus on the science itself rather than symbolic meanings. But the parallel exists nonetheless, a reminder that exclusion and marginalization don't just harm individuals, they potentially deprive humanity of insights those individuals might contribute. How many other discoveries have been delayed or lost because talented people were excluded from scientific careers? The dark matter revelation transforms our understanding of cosmic history in ways that continue to unfold. If visible matter is just a small fraction of what exists, then the story of how structures form in the universe needs to be rewritten. Dark matter, it turns out, forms the scaffolding on which visible structures build. Galaxies form within dark matter halos. Galaxy clusters are held together by dark matter gravity. The largest structures in the universe, the cosmic web of filaments and voids, are shaped primarily by dark matter's gravitational influence. This means that the universe we see through telescopes, for all its beauty and complexity, is really just decoration on an underlying architecture we can't directly observe. The bright galaxies we study are ornaments hanging on an invisible framework. The cosmic web we've mapped is the visible trace of a deeper structure built from matter that doesn't shine. There's something humbling about this realization, something that puts human understanding in its proper perspective. For centuries we've been studying the universe through light, using increasingly sophisticated instruments to detect fainter and fainter sources. Yet light shows us only a small fraction of what exists. The majority of the universe is literally dark to us, detectable only through its gravitational effects on the matter we can see. Vera's discovery reveals the limits of our vision, while simultaneously expanding our understanding of what exists beyond those limits. We can't see dark matter directly, but we know it's there. We can map its distribution, measure its mass, study its effects on cosmic evolution. The universe is stranger and richer than our eyes alone could reveal, full of mysteries that patient observation and careful reasoning can illuminate, even when direct vision fails. As the 1980s progress, Vera continues her work, extending rotation curve measurements to different types of galaxies, refining the techniques, training younger astronomers in the methods that reveal dark matter's existence. She's not content to rest on past discoveries, but pushes forward, always curious about what else the universe might reveal to careful observers. Her collaboration with Kent Ford continues producing important results, their partnership a model of how scientific cooperation should work. Mutual respect, shared goals, complementary skills combining to achieve what neither could accomplish alone. They published dozens of papers together, each one adding to humanity's understanding of how galaxies work. The dark matter mystery remains unsolved in its deepest sense. Decades after Vera's rotation curves revealed its existence, we still don't know what dark matter particles are. Particle physics experiments search for them in underground laboratories, trying to detect the rare interactions that might occur when dark matter particles pass through ordinary matter. So far, those searches haven't succeeded, suggesting that dark matter interacts even more weakly with ordinary matter than the simplest theories predict. But the search continues, driven by the certainty that dark matter exists, even if we don't yet know its nature. Vera's observations guarantee that the search is worth pursuing. The rotation curves don't lie. Galaxies contain invisible matter. Understanding what that matter is represents one of the great unsolved problems in physics, a mystery that bridges particle physics, cosmology, and our most fundamental theories about how reality works. For Vera, there's satisfaction in having revealed a genuine mystery, in having found a question so profound that answering it will require new physics. Science thrives on mysteries, on questions that push beyond current understanding. The dark matter problem is exactly the kind of mystery that drives scientific progress, well established observationally, deeply puzzling theoretically, demanding new insights to resolve. The woman who learned to work in shadows has given the scientific community a shadow to study. The gravitational shadow of matter that shapes everything, yet remains fundamentally mysterious. It's a fitting legacy for someone whose career was shaped by being overlooked and excluded. She found what was being overlooked, revealed what had been excluded from our cosmic census. And in doing so, she transformed our understanding of the universe from one where visible matter dominates to one where invisible matter holds everything together. The cosmos we inhabit is mostly dark, mostly hidden, mostly mysterious, but it's also mostly discoverable if we're patient enough, careful enough, willing to trust observations even when they challenge everything we thought we knew. Vera Rubin looked into the darkness and found that it was full of matter, full of mass, full of gravitational influence that shapes everything we can see. The universe is far stranger than we imagined, far richer in its composition, far more mysterious in its deepest nature. And that mystery, that darkness full of undiscovered truths, continues to call to astronomers and physicists today, inviting them to follow where Vera's observations led, into the shadows that hold the cosmos together. Imagine a lecture hall at the University of California in the autumn of 1982, where afternoon light slants through tall windows and catches dust motes drifting like miniature galaxies through the still air. The seats fill with students and faculty and curious townspeople who've heard that someone is coming to talk about invisible matter in the universe, a concept that sounds like science fiction but apparently isn't. They settle into wooden chairs that creak with the accumulated weight of decades, opening notebooks, adjusting glasses, waiting to hear what this woman from Carnegie has discovered. Vera stands at the podium with slides ready, her notes arranged in the particular order she's learned, works best for explaining dark matter to people encountering the concept for the first time. She's done this often enough now that the nervous energy of early talks has settled into something more like anticipation. There's pleasure in watching understanding dawn on faces, in seeing someone grasp for the first time that the universe is far stranger than they imagined. "Look up at the night sky," she begins, her voice carrying that particular warmth that comes when someone genuinely loves what they're talking about. "And everything you see, every star, every planet, every glowing nebula, represents less than 15% of what's actually there. The rest is hiding. Not behind clouds or dust, but in plain sight. We know it exists because of how it pulls on the things we can see." She clicks to the first slide, showing the Andromeda Galaxy in all its spiral glory, and you can hear the subtle intake of breath from the audience, even in a projected image, even reduced to dots of light on a screen. Andromeda is beautiful. Hundreds of billions of stars arranged in graceful curves that seem to defy the chaos you'd expect from random processes. "This is what we see when we look at a galaxy," Vera continues. "Light from stars, mostly. Some glowing gas. Beautiful, certainly, but incomplete. It's like looking at a city at night from an airplane. You see the lights, the bright spots, but you miss most of what's actually there." She clicks to the next slide, showing a rotation curve, velocity plotted against distance from the galactic centre. To most of the audience, it probably looks like just a graph, abstract and technical. But Vera has learned how to make graphs tell stories, how to transform data points into narratives that reveal cosmic truths. This line shows how fast stars are moving at different distances from the galaxy's centre, she explains, tracing the curve with a pointer. If visible matter were all that exists, this line should drop off at large distances. But it doesn't. It stays flat, which means something invisible is out there, pulling on those stars, keeping them moving faster than they should. The question period that follows reveals the hunger people have for understanding mysteries that exist beyond everyday experience. A young woman near the front asks how we can be sure dark matter isn't just ordinary matter we're missing, faint stars or planets or cosmic dust. Vera's answer is patient, detailed, walking through the calculations that show why conventional explanations don't work. An elderly man in the back row wants to know what dark matter is made of, and Vera admits with refreshing honesty that nobody knows yet. We can tell it's there, we can measure its mass, we can map how it's distributed, but what it actually is, that's one of the great unsolved mysteries in physics. There's something democratic about these public lectures, about the way cosmic knowledge flows freely to anyone curious enough to show up and listen. Vera believes in this deeply, this idea that understanding the universe shouldn't be reserved only for those with advanced degrees and institutional credentials. The cosmos belongs to everyone, she thinks, and so should knowledge about how it works. After the lecture, people cluster around the podium with follow-up questions, or just wanting to say thank you, or sharing their own experiences of looking up at the night sky and wondering. Vera stays as long as anyone wants to talk, answering questions until the custodian starts pointedly straightening chairs and switching off lights. But these public moments, important as they are, represent just one aspect of how Vera shares the dark matter revelation. The more intimate teaching happens in her office at Carnegie, where young astronomers, particularly young women, come seeking advice about navigating a field that still doesn't always welcome them. The office itself is a comfortable clutter of papers and books, star charts pinned to walls alongside children's drawings from years ago that Vera can't bring herself to remove. Sunlight filters through dusty windows, illuminating the organized chaos of an active scientific mind. A graduate student sits in the chair across from Vera's desk, nervously explaining her research project and the skepticism she's encountering from her advisor. "He keeps saying my observations must be wrong," the student says, frustration evident in her voice. "But I've checked everything multiple times. The data is solid." Vera listens with a kind of attention that makes people feel truly heard, not interrupting, letting the student articulate the full scope of her concerns. When she finally speaks, her voice carries the weight of someone who's navigated similar challenges. "The data will speak for itself," she says quietly, "if you're patient enough to let it. Don't get bullied into changing observations just because they make people uncomfortable. Some of the most important discoveries come from results that don't match expectations." She talks about her own experience with rotation curves, the years of skepticism she faced, the way persistence eventually won out over dismissal. "People told me I must be wrong for almost a decade," she says, "but the observations kept showing the same thing, galaxy after galaxy. Eventually, the evidence becomes impossible to ignore." The student leaves looking less burdened, carrying with her not just technical advice but something more valuable, the understanding that she's not alone in facing doubt and dismissal, that persistence matters, that good science eventually prevails even when it challenges established beliefs. These mentoring conversations happened dozens of times through the 1980s, in Vera's office, or over coffee in Carnegie's cafeteria, or during car rides to observatories where the real work of astronomy happens. Each conversation is different, shaped by the particular challenges each person faces, but they share common threads: the importance of trusting your observations, the value of patience, the need to believe in your work even when others don't. Kent Ford continues working alongside Vera through these years, their partnership a steady constant in a field that's transforming around them. They've been collaborating for over 2 decades now, developing the techniques that reveal dark matter, refining the instruments that make precise measurements possible. Their relationship has evolved into something beyond mere professional cooperation, a deep mutual respect built on years of shared work toward common goals. Watch them at an observatory on a cold night in the mid-1980s, moving through the familiar choreography of preparing for observations. Kent adjusts the spectrograph with the practiced ease of someone who's done this thousands of times, his hands steady despite the chill. Vera reviews the target list, checking coordinates, planning the sequence of observations that will make best use of the limited dark hours. They don't need to talk much anymore. The work has its own rhythm, perfected through repetition, each person knowing their role and trusting the other to fulfill theirs. There's comfort in this kind of collaboration, in working alongside someone who understands not just the technical aspects, but also the deeper purpose, the desire to understand how the universe works, one careful observation at a time. The papers they publish together become foundational texts in galactic dynamics, cited by hundreds of other researchers building on their work. But for Vera and Kent, the papers themselves are almost secondary to the observations they're based on. The real work is the nights at the telescope, the careful measurements, the patient accumulation of data that gradually reveals patterns invisible to casual observation. Vera's family watches her growing fame with a mixture of pride and the complicated feelings that come from sharing someone with the world. Her children are adults now, or nearly so. Robert pursuing his own career, Lucy establishing herself as a writer, David and Judith finding their own paths. They've grown up with a mother whose attention was always divided between them and distant galaxies. who missed some school events because of observing runs, but who also showed them that women could be scientists, that curiosity deserved to be pursued. Robert Rubin, Vera's husband through all of it, continues to be her partner in the fullest sense. He's retired now from his own career in physical chemistry, but his support for Vera's work hasn't diminished. He manages household details that might otherwise pull her away from research, creates space for her to travel to conferences and observatories, celebrates her achievements while helping her stay grounded. There's something beautiful about a partnership that's weathered decades and come out stronger, that's navigated the impossible juggling act of dual careers and child-rearing and all the ordinary challenges that strain relationships. They've built something together that's larger than either could have managed alone. A family, yes, but also a life that made room for cosmic discovery alongside domestic joy. The awards continue arriving through the mid-1980s, each one acknowledging Vera's contributions to astronomy. The National Medal of Science comes in 1993, presented at a White House ceremony where Vera stands alongside other scientists who've made fundamental contributions to human knowledge. The Gold Medal of the Royal Astronomical Society, the same medal once awarded to Caroline Herschel, one of the first female astronomers to gain recognition for her work. But perhaps more meaningful than the formal awards are the informal acknowledgements from colleagues who've built their careers on the foundation Vera established. Young astronomers approach her at conferences to say that her work inspired them to enter the field, that her example showed them persistence matters, that her discoveries opened up entire new avenues of research. She deflects the praise with characteristic modesty, redirecting credit to collaborators and to the collective nature of scientific progress. "I just looked carefully at what the observations showed," she might say. "The universe did the interesting part." This humility isn't false modesty, but genuine perspective. Vera understands that individual scientists are just temporary caretakers of knowledge, adding their small contributions to a stream of understanding that flows through generations. Her rotation curves reveal dark matter, but that revelation built on Fritz Zwicky's earlier insights, and it will be extended by future astronomers using instruments she can barely imagine. The dark matter story itself continues to unfold in unexpected directions through the 1980s and 90s. Gravitational lensing observations confirm the presence of invisible mass in galaxy clusters. Cosmic microwave background measurements reveal patterns that require dark matter to exist. Computer simulations show how dark matter provides the scaffolding on which visible structures form. Each new line of evidence adds confidence to the reality of dark matter while deepening the mystery of what it actually is. Particle physics experiments search underground for the rare interactions that might reveal dark matter's nature. Theoretical physicists propose exotic particles with names that sound like science fiction: neutralinos, axions, sterile neutrinos. But despite decades of searching, dark matter particles remain undetected directly, hiding as stubbornly from particle detectors as they do from telescopes. Vera follows these developments with interest, but maintains her focus on observations. Let the theorists worry about what dark matter is made of, she figures. Her contribution is establishing beyond doubt that it exists, that its effects are real and measurable, that the universe is far richer and stranger than our eyes alone could reveal. In her office at Carnegie, surrounded by decades of accumulated papers and data, Vera sometimes reflects on the arc of her career, from the 10-year-old girl watching stars move across her bedroom window to the elder stateswoman of astronomy, whose discoveries changed how humanity understands the cosmos. The journey has been longer and more challenging than she could have imagined. filled with obstacles that might have stopped someone with less determination. But here she is, still curious, still asking questions, still believing that patient observation can reveal truths that flashier approaches miss. The woman who learned to work in shadows has illuminated the cosmic shadows that hold everything together, and in doing so, she's shown that exclusion doesn't have to be destiny, that being pushed to the margins can provide perspectives the mainstream desperately needs. The Invisible Woman has revealed the invisible universe, and both, it turns out, were there all along, waiting for someone to look carefully enough to notice them. Snow falls outside Vera's office window at Carnegie on a December morning in 1996, each flake drifting down with the same patient inevitability that governs the motion of galaxies through space. She watches them accumulate on the windowsill while her coffee grows cold in its mug, her mind half here in this warm room and half somewhere in the distant universe where dark matter weaves its invisible web through the cosmos. 68 years old now, though the number feels abstract, disconnected from the person she feels herself to be inside. Her hands rest on the desk in front of her, hands that have written thousands of observations, adjusted countless telescope settings, held babies who are now adults with careers of their own. There's arthritis in the joints now, a stiffness that wasn't there even 5 years ago, making the fine work of data analysis more effortful than it used to be. The office has grown around her like a tree adding rings, each layer marking a different era of her career. File cabinets from the 1960s sit next to newer models from the 80s. Photographs on the walls span decades, her children at various ages, Kent Ford adjusting equipment at an observatory, colleagues long retired or passed on. There's a drawing that Judith made in elementary school showing her mother at a telescope, the stars rendered as five-pointed shapes like a child's simplification of something too complex to capture accurately. The phone on her desk has been ringing more lately with journalists wanting to talk about dark matter, about the new discoveries suggesting the universe contains something even stranger, this dark energy that seems to be pushing space itself apart. She answers when she can, explaining once again that yes, most of the universe is invisible, and no, we still don't know what dark matter is made of, and yes, isn't that wonderful that there are still such profound mysteries waiting to be solved? But some mornings, like this one, she lets the phone ring through to voicemail. There's a particular quality to winter mornings when snow is falling that demands quiet, that makes speech feel like an intrusion. She sits with her cold coffee and watches the flakes accumulate, thinking about nothing in particular and everything at once. Kent Ford's retirement party had been last month, a gathering in Carnegie's conference room with cake and speeches and the particular bittersweet atmosphere that comes with endings. He'd worked at Carnegie for 35 years, the last 30 of them in close collaboration with Vera. They'd observed hundreds of galaxies together, developed techniques that became standard in the field, built a partnership that produced some of the most important work in modern astronomy. "I'm not really retiring," he'd said, during his speech, to gentle laughter from the assembled colleagues. "I'm just going to stop coming to the office every day." The work continues. Vera had smiled at that, understanding exactly what he meant. You don't retire from curiosity. You don't stop wondering about the universe just because you've reached a certain age. The questions continue as long as consciousness does, maybe longer. Her own retirement has been suggested more than once, gently, carefully by administrators who worry about her health, and by family members who think she should slow down. But the idea feels wrong somehow, like suggesting she stopped breathing because she's been doing it for so long. What would she do with days empty of observations and analysis? How would she fill the hours that have been structured around cosmic questions for more than 4 decades? So she continues, adjusting her patterns to accommodate the constraints that age imposes, but not surrendering to them. Shorter observing runs now, with younger colleagues handling the physical demands, while she provides guidance and experience, more time reviewing others' data than gathering her own. The work changes shape but doesn't stop. A graduate student knocks on her doorframe. The door itself stands open, as it almost always does, an invitation to anyone with questions. The student is young, maybe 25, with nervous energy radiating from her like heat from a star. She's working on mapping dark matter distribution in galaxy clusters and has encountered data that doesn't match her expectations. "Come in," Vera says, gesturing to the chair across from her desk. "Tell me what you're seeing." The student spreads papers across the desk surface, plots and graphs and images marked with annotations. Her hands shake slightly as she explains the problem. The dark matter seems to be distributed differently than the simulations predict, clumped in ways that don't make sense according to current models. Vera leans forward, studying the data with the same careful attention she brought to her first rotation curves decades ago. There's a pattern here, something trying to reveal itself through the numbers and plots. The student is worried she's made a mistake, that her observations are wrong. Vera recognizes this fear. She's felt it herself countless times. That moment of doubt when your data contradicts expectations, and you wonder if the universe is strange or you've just screwed up. "Show me how you calibrated the observations," Vera says quietly, and they spend the next hour going through every step of the analysis, checking for errors, verifying assumptions. The data holds up. The strange distribution is real, not artifact. "This might be important," Vera finally says, and watches relief flood across the student's face. Not relief that the work is done, but relief that she's not crazy, that what she's seeing is real. "Write it up carefully. Show your work. Let the observations speak for themselves." The student leaves carrying her papers and something else, the confidence that comes from having your observations validated by someone who understands how hard it is to trust data that challenges conventional wisdom. Vera watches her go, thinking about all the young astronomers she's mentored over the years, the doors she's tried to hold open that were closed to her. The snow has stopped falling outside, leaving the world transformed into something clean and unmarked. Vera's coffee is stone cold now, undrinkable, but she doesn't move to make a fresh cup. There's something peaceful about this moment, the quiet office, the winter light, the sense of being suspended between past and future while existing fully in the present. Her children call regularly, checking in, making sure she's taking care of herself. Robert has children of his own now, Vera's grandchildren, though the word still feels strange on her tongue. They're curious kids, full of questions about stars and planets and whether there's life elsewhere in the universe. She answers as best she can, finding joy in their wondering, seeing something of her 10-year-old self in their wide-eyed fascination with the cosmos. Lucy sends her articles she's written about science communication, continuing the family tradition of trying to make cosmic knowledge accessible to everyone. David checks in from his work in another field entirely, reminding Vera that there are many ways to be curious about the world. Judith, the youngest, has developed her own interests far from astronomy, but she calls anyway, wanting to hear her mother's voice, wanting to maintain connection across the distance that adult lives create. Robert Rubin, her husband through everything, her partner in the truest sense, has slowed down more than Vera has, his body giving out in ways that worry her when she lets herself think about it too much. They've been married for nearly 50 years now, an entire lifetime spent together, and she can't quite imagine what the world would feel like without him in it. Some evenings they sit together in the living room of their home, not talking much, just existing in the same space while darkness gathers outside the windows. He reads his books on chemistry, she reviews her papers on dark matter, and the silence between them carries the weight of decades of shared experience. "Do you ever think about retiring?" he asked one evening, the question emerging from nowhere, or perhaps from everywhere. "No," she says, and then more honestly, "Sometimes. But I wouldn't know what to do with myself." "You could rest," he suggests, but they both know that's not really an option. Not for someone whose mind has been active for 68 years and shows no sign of wanting to stop. The dark matter mystery itself has deepened rather than resolved over the decades since Vera's rotation curves first revealed its existence. Particle physicists have built detectors deep underground, waiting for dark matter particles to reveal themselves through rare collisions with ordinary matter. Astronomers have mapped dark matter's distribution across cosmic scales, revealing how it forms the scaffolding on which visible structures build. But despite all this effort, despite decades of searching and theorizing and observing, nobody knows what dark matter actually is. The particles remain undetected. The fundamental nature of this substance that makes up most of the universe's matter remains mysterious. Vera finds this oddly satisfying. She's given the scientific community a genuine mystery, a question so profound that answering it will require new physics, new understanding of how reality works at its deepest levels. That's worth more than having all the answers, providing future generations with worthy questions to pursue. A conference invitation arrives in her mail asking her to give the keynote address at a symposium on galactic dynamics. She accepts, as she usually does, though the travel is growing more tiring. At the conference, she'll stand before hundreds of astronomers, many of them young enough to be her grandchildren, and talk about the rotation curves that revealed dark matter, about the decades of work that built our current understanding. And afterward, during the question period, someone will inevitably ask when she's planning to retire. She'll smile, give some version of the answer she's given dozens of times before, that the work continues as long as the questions do, that retirement feels premature when there's still so much to discover. What she won't say, what she can barely articulate even to herself, is that the work is who she is. Take away the observations and the analysis and the patient pursuit of cosmic understanding, and what's left? She doesn't know, and at 68 she's not particularly interested in finding out. The snow outside her office window has started falling again, heavier now, creating a white curtain between her and the world beyond. Vera watches it with the same attention she brings to everything, noticing the patterns, the way individual flakes swirl in currents of air, too subtle to see directly, but real enough to shape their motion. Somewhere out there, in the darkness between galaxies, dark matter continues its patient work, holding structures together, shaping the cosmos at the larger scales, remaining mysterious despite humanity's best efforts to understand it. And here, in this warm office with its accumulated decades of papers and photographs and coffee-stained notebooks, Vera Rubin continues her own patient work. Guardian of the shadows, someone called her once. She liked that, not because it suggests ownership or control, but because it captures something true about her relationship with the darkness she discovered. She doesn't own these cosmic shadows, doesn't control them, but she watches over them, in a sense, tends the knowledge we've gathered about them, protects the mystery from being dismissed or forgotten. The invisible woman and the invisible universe, still keeping each other company after all these years, both of them waiting to reveal their secrets to anyone patient enough, careful enough, curious enough to look closely at what everyone else is overlooking. On December 25th, 2016. Morning light creeps across a bedroom in Princeton, New Jersey, touching the edges of furniture that's accumulated the patina of decades. A dresser from the 1960s, a chair where Robert Rubin sits reading on quiet evenings, photographs on the nightstand showing children and grandchildren at various ages, faces changing and not changing simultaneously. Vera sleeps in the bed she's shared with Robert for more than 60 years, her breathing shallow but steady, her face relaxed in a way it rarely is during waking hours. 88 years have left their marks, lines around her eyes from squinting at telescope eyepieces, arthritis in hands that once adjusted instruments with practiced precision, a body that's grown frail even as the mind inside remains sharp and curious. She doesn't wake up. The passing is so quiet it seems almost like she's just sleeping deeper than usual, that any moment she might stir and ask what time it is, whether there's coffee ready, what observations are scheduled for tonight, even though she hasn't been to an observatory in months. But the stillness has a different quality to it, a finality that Robert recognizes even before he touches her hand and finds it cooling. He sits beside the bed for a long time, holding that hand, not calling anyone yet, just existing in this last private moment before the world rushes in with its condolences and arrangements and the necessary machinery of dealing with death. Outside, somewhere down the street, children are probably opening Christmas presents, their excited voices carrying through the cold morning air. Life continuing its ordinary rhythms while here, in this quiet room, something extraordinary has ended. The news travels through networks, both official and informal. Phone calls to the children first, Robert's voice breaking as he tells them their mother is gone. Emails to colleagues at Carnegie who need to know. And then, inevitably, the information spreads outward like ripples from a stone dropped in still water, reaching across continents and time zones as astronomers wake to the news that Vera Rubin has died. At Carnegie, on the first workday after Christmas, people walk past her office with careful steps, as if noise might disturb something sacred. The door stands closed, and through its small window you can see papers still scattered across her desk, notes about dark matter distribution, a letter half written to a graduate student asking for advice, a coffee mug with the faded logo of some long-ago conference. Someone has already placed flowers outside the door. By afternoon there will be more, roses and lilies and simple wildflowers, notes attached saying thank you or rest in peace or we'll miss you. One note, in a child's handwriting, says thank you for finding the invisible stuff, and includes a drawing of stars. Kent Ford hears the news at home, alone now that his own wife has passed, and he sits in his living room surrounded by photographs from decades of collaboration. There's one of him and Vera at an observatory in the 1970s, both of them younger than seems possible, adjusting equipment with expressions of concentration. He remembers that night, clear and cold, the Andromeda Galaxy rising in the eastern sky, the sense of being on the edge of discovering something important. He cries, which surprises him. He thought he'd used up his tears when his wife died, thought he had no more grief left to give. But apparently loss doesn't work that way. Each ending creates its own hollow space, its own particular absence that nothing else can fill. The funeral happens on a grey day when the sky matches the mood, clouds low and heavy with the threat of snow that never quite arrives. The chapel fills with people, family in the front rows, colleagues from Carnegie, former students who've flown in from around the world, astronomers whose careers were built on foundations Vera established. Robert Rubin sits between his children, moving slowly, his face carrying 90 years of life and the particular devastation that comes from losing your partner of 6 decades. Lucy holds his hand on one side, Robert Jr. on the other, the family forming a unit of mutual support against the weight of what they're losing. The eulogies speak about Vera's contributions to science, her discovery of dark matter evidence, her patience as a mentor. But they also talk about smaller things, her sense of humour, the way she made time for anyone with genuine questions, her ability to explain cosmic mysteries as if she were telling stories to friends over coffee. One colleague describes how Vera once spent an hour helping him fix a broken spectrograph when she could have been analysing data, never making him feel inadequate for not knowing how to solve the problem himself. A former student, now a professor at MIT, describes the day Vera looked at her rotation curve measurements and said, "This is important work," with such conviction that all the students' doubts evaporated. She saw things in people before they saw them in themselves, the student says, her voice breaking slightly. She believed in observations before they were fashionable, in people before they were established. After the service, people gather in small clusters outside the chapel, talking in low voices about Vera and dark matter, and the strange way the universe keeps revealing itself to be weirder than anyone expects. Snow finally begins to fall, light flakes that melt almost as soon as they touch the ground, here and then gone, like memory trying to hold onto something that keeps slipping away. Back at the house in Princeton, family and close friends gather for the reception, that peculiar ritual where grief mingles with food and stories, and the strange obligation to socialize at a time when everyone would prefer to be alone with their thoughts. Robert sits in his favourite chair, accepting condolences with a kind of numb grace, saying thank you to people whose faces blur together. Judith brings him tea he doesn't drink. Lucy shows him photos someone brought, Vera at various ages, various conferences, various moments in a life fully lived. He looks at each one with careful attention, as if seeing these images for the first time, though he's seen most of them hundreds of times before. The grandchildren move through the house with the uncomfortable energy of young people confronting mortality. Some of them remember Vera clearly, the grandmother who always had time for their questions about stars, who never talked down to them, who treated their curiosity as something precious rather than annoying. Others, the youngest ones, will grow up with only vague memories or family stories, second-hand knowledge of someone who shaped their family, but who they'll never really know. In the days and weeks that follow, the tributes continue to arrive. The astronomical community names the Large Synoptic Survey Telescope in Chile the Vera Rubin Observatory, a massive instrument that will continue the work she started, mapping galaxies, understanding cosmic structure, searching for the dark matter that makes up most of the universe's mass. But the real memorial exists in quieter forms. At observatories around the world, astronomers measure rotation curves using techniques Vera pioneered, each observation a continuation of her work. In underground laboratories, detectors wait for dark matter particles to reveal themselves. The search is motivated by the certainty Vera's observations provided that something invisible is out there. In classrooms, students encounter her story as part of learning about dark matter. They see photographs, the young woman denied admission to Princeton, the researcher at Carnegie making observations that would change cosmology, the elder scientist whose patience and precision revealed cosmic truths. Some of those students, particularly young women facing obstacles of their own, find inspiration in her example. The papers she wrote continue to be cited years after her death. Dozens, then hundreds, then thousands of citations accumulating as new research builds on foundations she established. Her rotation curves appear in textbooks. Her careful methodology becomes the standard for galactic dynamic studies. Her name becomes synonymous with the discovery that most of the universe is invisible. The house in Princeton eventually sells to a new family who probably don't know that someone who found the missing universe once lived there. They repaint the walls, replace worn carpets, make the space their own. But for a while, maybe, Vera's presence lingers in ways beyond physical. In the backyard where she sometimes stood on clear nights, looking up at stars she'd spent her life studying, in the small desk by the window where she worked on papers even after retiring. Robert follows her within a few years, his body finally giving out, his heart perhaps unable to keep beating without her nearby. They're buried together under a simple stone that doesn't mention dark matter or galaxies or any of the cosmic mysteries she spent her life unraveling. Just names and dates marking lives that intersected and held together for 60 years. The children scatter her ashes later, privately, in places she loved. Some go into the earth near their home. Some are released into wind during a visit to an observatory where she made important observations. The physical matter that was Vera Rubin disperses into the environment, returning to the cycle of atoms that makes up everything, joining the cosmic recycling that turns stars into planets, into people, and back again. But the observations remain. The rotation curves still show stars moving too fast in galactic outskirts. The dark matter evidence still demands explanation. The mystery she revealed continues calling to astronomers and physicists, inviting them into questions that may take generations to answer. Late at night at observatories, when astronomers point telescopes at distant galaxies and split their light into spectra, their continuing work Vera started. When detectors deep underground wait patiently for dark matter particles that haven't been detected yet, they're following trails she blazed. When students learn that most of the universe is invisible, they're encountering a truth she made undeniable. The Invisible Woman revealed the invisible universe. Both were there all along, waiting for someone to look carefully enough to notice them. And now both continue their patient existence. Dark matter in the cosmos, Vera's influence in the countless minds she shaped, the questions she taught people to ask, the careful methodology she modelled for approaching mysteries. Somewhere a young astronomer, maybe a woman facing skepticism about her observations, remembers Vera's example and decides to trust her data anyway. Somewhere a graduate student measures a rotation curve and adds one more point to the accumulated evidence about dark matter. Somewhere a child looks up at the night sky and wonders what's really out there, what secrets the darkness holds. And the universe, patient and mysterious, continues its slow revelation, holding most of its matter invisible, maintaining its secrets, inviting curious minds to discover what lies hidden in the shadows between stars. Imagine settling deeper now into whatever comfortable space has held you through this long journey. Your bed, perhaps, or that favourite chair that's moulded itself to your body's contours. Or maybe you're lying back, where you can see stars through a window, those same distant suns that Vera spent her life studying. The night has deepened around us as we've drifted through her story, and perhaps you're feeling that particular heaviness that comes when consciousness starts to blur at its edges, when thoughts become less linear and more dreamlike. We've travelled together from a girl's bedroom in 1930s Washington, D.C., where a 10-year-old watched stars move across her window and wondered why, to observatories where rotation curves revealed that most of the universe is invisible, to a quiet morning in Princeton where a life fully lived came to its gentle end. Nearly 9 decades compressed into a few hours of storytelling, yet somehow the journey feels both complete and infinite, like looking into those cosmic structures Vera studied, patterns that repeat at every scale, mysteries that deepen rather than resolve. The transformation we've witnessed defies the normal arc of how lives unfold. Here was a young woman told she didn't belong in astronomy, rejected by institutions that couldn't imagine someone of her gender making meaningful contributions to science. And yet, she persisted, not through dramatic rebellion, but through patient accumulation of observations, through careful attention to what the universe was trying to tell anyone willing to listen. There's something almost poetic about the parallel, how someone made invisible by prejudice revealed that most of the universe itself is invisible. The excluded observer finding the excluded matter, both of them hidden in plain sight, both of them essential to understanding how everything holds together, both of them waiting for someone to look carefully enough to notice them. Vera's discovery of dark matter evidence didn't just change astronomy, it transformed how we think about our place in the cosmos, about the relationship between what we can see and what actually exists. For all of human history, we've studied the universe through light, building increasingly sophisticated instruments to detect fainter sources, to see farther into space and deeper into time. Yet light shows us only a small fraction of what's out there. The majority of the universe's matter is literally dark to us, detectable only through its gravitational effects on the matter we can observe. This revelation is humbling in the best possible way. It reminds us that our senses, our instruments, our entire framework for understanding reality captures only a piece of what exists. Most of the cosmos remains mysterious, hidden, waiting to be discovered through patient observation and careful reasoning rather than direct vision. But perhaps what's most remarkable about Vera's story isn't the discovery itself, though that's certainly significant, but the journey that made it possible. She learned to work in shadows because mainstream astronomy pushed her there. She developed careful observational skills because she couldn't rely on institutional support. She trusted her data over conventional wisdom because she'd spent decades having her insights dismissed. The exclusion that should have ended her career instead sharpened her vision, taught her to see what others were overlooking, prepared her to discover cosmic shadows that hold everything together. In a very real sense, the barrier she faced became the source of her greatest strength. The invisible woman was perfectly positioned to find the invisible universe. Think about the patience required for her work. Decades of observations, hundreds of galaxies, rotation curve after rotation curve, showing the same impossible pattern. No sudden eureka moment, no dramatic revelation, just the slow accumulation of evidence that couldn't be ignored. This is what real science looks like most of the time. Not flashes of genius, but patient methodology, careful attention to detail, willingness to trust observations even when they contradict everything you thought you knew. And through it all, Vera maintained her dual life, astronomer and mother, researcher and wife, someone who studied the largest structures in the universe while also managing the small daily details of family life. She refused to choose between these identities because she understood, perhaps better than the culture around her, that they weren't contradictory. You can love your children and also love distant galaxies. You can care deeply about domestic life while also caring about cosmic mysteries. Her partnership with Robert Rubin deserves its own recognition, a relationship that survived and even flourished through challenges that would have destroyed most marriages. He supported her work not as a favor, but as a partner who understood that her astronomical research was as important as his own career. In a time when such partnership was rare enough to be remarkable, it made the difference between Vera abandoning science or continuing to pursue it. The dark matter mystery itself remains unsolved, exactly as Vera left it. We know it exists. The rotation curves don't lie. The gravitational effects are real and measurable. But we still don't know what dark matter particles are, how they interact beyond gravity, why they're distributed the way observations reveal them to be. The searches continue in underground laboratories and particle accelerators, driven by the certainty Vera's observations provided that something invisible is out there waiting to be understood. Perhaps this is the most fitting legacy, not answers but questions worthy of pursuit, mysteries so profound that solving them will require new physics, new understanding of reality at its deepest levels. Vera gave the scientific community a genuine puzzle, and puzzles are what drive progress, what keep curious minds engaged across generations. As you drift towards sleep tonight, perhaps you'll carry with you some piece of Vera's story, the image of a girl watching stars move across her window, or a woman at a telescope revealing cosmic truths, or the understanding that most of what exists remains hidden from casual observation. Perhaps you'll think about how exclusion and limitation don't have to define us, how patient observation can reveal wonders that flashier approaches miss, how darkness itself can be full of meaning and substance. The stars visible through your window, if you're fortunate enough to see them past the glow of human civilization, shine with light that began its journey years or centuries ago. That light carries information about stellar temperatures and compositions, about distances and motions through space. But it shows us only the bright islands, floating in an ocean of darkness that holds everything together. Vera Rubin looked into that darkness and found that it was full of matter that shapes galaxies, full of gravitational influence that sculpts cosmic structure, full of mysteries that will occupy human minds for generations to come. The woman who learned to work in shadows revealed that shadows hold the cosmos together, and in doing so, she gave us permission to trust what we observe even when it contradicts what we expect, to value patience over speed, to understand that being excluded from the mainstream sometimes provides exactly the perspective the mainstream needs. Sweet dreams. Fellow travellers through space and time, rest well under stars held together by forces we cannot see but know exist through their effects. And remember that the invisible woman found the invisible universe, proving that both were there all along, waiting for someone to look carefully enough to notice them. The darkness is not empty. It's full of mysteries waiting to be discovered, full of matter holding everything together, full of questions inviting patient observation and careful thought. And somewhere in that darkness, Vera Rubin's legacy continues, in the rotation curves still being measured, in the young astronomers she inspired, in the understanding that the cosmos is far stranger and richer than our eyes alone could ever reveal. Sleep peacefully. The universe keeps its secrets, but it also shares them with anyone curious enough, patient enough, determined enough to look beyond the obvious and ask what else might be there. Clear skies and gentle revelations, the Sleepy Astronomer.